Today I'm going to tell you about homework 6, documenting in an LT spice. This might be a little bit complex, so that's why there's a video just to walk you through it. But basically you are going to derive and verify in LT spice a unique waveform. And to generate that unique waveform, you click on homework 6A. And you can do it from here, or you can do it from assignments in 6A. And when you launch it, you will get this. All right, and you would just take a screen grab using the snippet tool, Snagit, or the screen tool of your choice, right? And grab from this corner all the way to this RMS value. All right, so I've actually given you what the RMS should be, and you can use that to help verify your work. But everybody will have a unique ID and a unique waveform. Now, this might be the first time you're doing an engineering type report, right? And so I have a lot of information to tell you how to go about it. So if we go to homework 6, documenting an LT spice, the assignment is here in a Google Doc, right? And you have all the instructions, right? The report needs to be written in Google Docs. I even have a template. I even have an example of a report just on voltage division. But you need to name the file, year, month, day, homework 6, your student ID, and your family name. And then give the TA and the instructor comment privileges, because we'll be trying to use formative feedback model where we tell you what to improve and you improve it until you get the grade you want. My sample was about 4 to 5 pages. You should be around that. And then here's some resources. Here's a tutorial on using LT Spice. It's a huge tutorial. But you really only need to do chapter 1, right? And it tells you everything. Now, if you want to go more, right, here you go. Actually, even at the beginning of 98, you might be able to understand all of chapter 3, okay? But this is for part of a much bigger thing. It's not just a 98 manual, all right? This is like the notes, just the absolute bare minimum. All right, on LT Spice. This is a summary of creating the figures properly so that you don't get dinged. But making a proper figure in LT Spice is really important. And if you look at the rubric, you need to take it seriously. I even have notes of kind of the good things and the bad things. And yeah, I guess I start off with bad, right? You can't use like C code constructs. That this particular symbol means convolution, not multiply. None of this, right? This would be a properly done equation. And then I just go through showing you all the ways figures can look bad, but I always end with how it would look good, all right? And then here, if you don't, you can access LT Spice remotely. Like if you can't download it on your Mac, right? This should work. It might be a little bit off here and there, but you shouldn't have to. And LT Spice is free anyway. So here's the template, which it's almost like a homework solution, okay? But you need to, so you can make a copy of this, right? You need your own title, your own name, your own student ID. The abstract, it's actually written last. But I put in what was the signal that I derived, and what did I find to be the RMS, and what was the error. Okay, and my Grammarly likes to complain about some things, so that's why you might be seeing some red. In the introduction in theory, this yellow part is you should do your own, describe a real world example. You have to write this part, and I don't really have a sample. This is like a bare minimum, right, of what I would expect. You know, this is what RMS is. This is why it's important. Here's the equation, right? And then here's the figure I did, which was a sine wave. You guys won't have sine waves, or this is sine squared, actually. And you won't have that. You'll have the trapezoid thing. But you can see that I grabbed it, right? And that was my figure 1. I have the ID and the frequency. You'll have different parameters. And then I just go through and I derive it. And every time I do a step, right? And steps are like, I substituted this. I did a trig identity. You don't have to show every time you do an algebraic maneuver, right? And in this case, yeah, integrating this is rather difficult. So I use a trig identity. And then I have to use a trig identity again. And so it actually looks more complicated than it really is. But I get, in my case, the square root of 6, right? Then I verify it in LT-SPICE, right? And this is how I did it. And these are my results. And then I say there's like a 0.01%, actually 11% relative error, right? And then I discuss it. Now, yeah, there's not a physical measurement, but the square root of 6, right, if you evaluate it out to that level of precision, is one thing, but LT-SPICE gives a slightly different thing. And I go into why it's doing that, right? And I even increase the accuracy of the simulation, but then it takes 28 seconds versus, 0.09 seconds. And then I just talk about it. And then here are my references. Now, yeah, these last three references, yeah, you'll probably use. It's actually kind of hard to find RMS references because it's used so much for so long, right? There's current things, right? And this was like on my application, all right? But you can find your own application or make up your own application of it. But that would be, and then if, there's something, when we're grading it, the teacher can make a comment, do this, do that, right? And, it's important to name your versions, right? Right? So I would name it version 1 and then upload it to Canvas, right? Because then when you fix it, right, the TA can go and click on, let's say, the next one, make some comments, you resolve everything, and then save it as version 2. It's easy to switch back and forth. Like, let's see if I just delete this, right? And now you can see everything I've done. And you can see that I just deleted it. Okay. But I don't want to do that. Okay. And I use Google Docs with my faculty friends to write NSF grants and technical work. And I find that it's pretty good for collaboration. And so rather than having an assignment where we just tell you what you got right and what you got wrong, no, I want to be collaborators with you to improve your reports until you master it, right? Or you get the grade that you want. I would hope you'd want a good grade. Anyway, that's that.